Hi everyone, my name's Joe Richmond-Knight. I'm a Field Applications Engineer for SYSGO, and we're here at Embedded World this year showing off our cybersecurity demo. So what we have here is effectively a security gateway, or I suppose a firewall, and we're demonstrating the use of some of the inherent features of PikeOS for implementing a cybersecurity gateway. And for this demonstration we're using the Xilinx KRIA board, and PikeOS is running on the Cortex-A cluster. So what you can see on the screen here is the user interface as part of the demo, and actually this really nicely visualizes what this demo is doing. So on the left hand side here and on the right hand side you see two Linux guest operating systems, and these are actually our own ELinOS OS. These are set up in what we call an immutable configuration. So that means the OS itself and the applications running within that can't change or can't be impacted. So this means inherently this is secure, right? So if there is some malicious activity or there's an attempt to modify one of the files in these immutable configurations, actually in this case it won't be possible. And in any event, when you reboot the Linux operating system, it will return back to its original state. Hence the term immutable. So these two Linux guests are representing two sides of the network here in the cybersecurity gateway. We have a trusted domain on the left and an untrusted domain on the right. So you could think of your trusted domain as your high security, safe network, perhaps your internal network, and this untrusted domain perhaps as the internet or another network you're connecting to. The system status in the middle here is representing the firewall, which is implemented in PikeOS. The main communication technology between these two Linux environments is our ARINC 653 style ports. Okay? So the way that the firewall is set up for this demo is under a normal condition. If I step back here, you'll see that the firewall is allowing bidirectional communication. So that means from partition A to partition B and vice versa. And if I move forward here, we have a LiDAR sensor, which is being used as a bit of a metaphor for maybe an intrusion detection system, maybe packet inspection, etc. So that means I can very easily trigger a threat state of the gateway. So in this threat state, you'll see that the trusted domain becomes protected, which means only the trusted domain is allowed to communicate outside. The outside can't then communicate in. So as I said at the beginning of the video, we're using some fundamental functions of PikeOS to implement this. The IPC, this concept of a data diode that can be set up very easily, and probably most importantly the separation kernel architecture, which is validated for safety, and in this case validated for cybersecurity up to Common Criteria EAL 5+.